Hello guys and welcome to part 6. This is the most exciting part as this is basically the brain of the pipeline. The machine learning model. And man, do I have a story to tell. Initially when I started, I ran into a cluster of problems, such as how will I train, validate and test the model, what models to use, number of epochs to use, how to pull the data from the database, how to save the predictions and a whole list of other problems. And if anyone's tell you machine learning is easy, clearly they have only used and trained their models on simple data, as a production-based ML model requires a lot of thinking and steps before we can get to the end goal. Focus on the end goal and you will stumble over everything, focus on the process and you reach the end goal faster. One of the most logical thing you can do when prototyping is to set all settings to the smallest or minimum to speed up testing and debugging. This ensures we are able to debug and write code faster. Then once everything is sorted and ready, you may apply the default or base settings. Okay, enough with the boring pep talk, let's get down to business. Our model is wrapped in a FASTAPI framework, meaning our training, validation, testing and live forecasting will be done here, no extra frameworks. As you can see, we have the root, train, validate and test tabs. On the train body, we have an input body, where we can enter out parameters. These parameters will be used for training, validation and testing. All this took some time. I did everything and recorded the video, hence mine's is complete. Testing time will vary as this is directly affected by the number of epochs, and the settings you apply for the model's hyperparameters. Another thing to note here is that, the model has been optimized, tested and vectorized. I have applied some vector functions to speed certain processes up to avoid excessive training time. Let me quickly explain. Say you use a function, maybe this function assigns what kind of model to use for a certain event. Instead of calling this function whenever we find a new event, we can call it once and assign the event its model type, then once all events are done, we discard it from memory. More often than not, you can cut training time by 10 to 50 times, yes you heard right, up to 50 times. For smaller models you may not really notice this as much, for bigger models like the recurrent neural network, a 50x drop in training time is very efficient. Then we will head over to VS Code to check our code. We have 5 scripts, main DB connector, train, validate and test. Again, I will not get into the thick of it, but I will leave it in my GitHub repo once the pipeline is complete so you guys can check it out. Also on the bottom left of the screen, we have a folder called Model Artifacts where our model weights and splits will be saved. Okay, now let's talk about the models I used and why I think it is a perfect solution for this problem. Firstly, we are dealing with economic news releases. They are released every single month, showing various values reflecting the state of various sectors and markets. Since this data has a date and time attached to it, any model dealing with sequence and order would be the most logical thing to use, and also, you cannot simply reshuffle and mix such data, as the state of the economy may have been different at that time, and randomizing your samples would be like taking a fried egg and using a freezer to uncook it. That would be very dumb, as the state of that egg has already changed, hence the same logic applies here. We have lots of data to train this model, however some events maybe have not been around for a long time or they may only occur once every 2 months, once a quarter, etc. So I decided to use the XGBoost model to train those particular events with 50 samples or less. Anything higher would strictly be trained with the RNN. I will not get into details here, the logic is fairly simple and understandable. Due to the nature of these events, the model's pipeline will be retrained every month. We will only make predictions for the current month using the previous month's data. Our goal here is to predict the value for the month, not for the next few months. External factors will not allow our model to predict beyond a month. For us to do that, we would have to find a way to add the external factors into the calculation. Things like incremental learning and continuous learning would be possible only if we can model those hidden factors, and also those methods are normally used for stream processing where there is a continuous stream of data. There will not be any Docker container for this section, due to various reasons. Let's say you wish to change the models used, you would have to manually adjust every single file used, update the Docker files, YAMLs and requirements file. On top of that, these Docker container take time to build. For this pipeline, I suspect it would take around 1 to 2 hours depending on your internet speed and also, it would use about 5 to 6 gigabytes of space, which is honestly crazy for a simple pipeline like this. For now, we will leave it like this, as on the cloud we have online notebooks and GPU that will handle everything for us. In the next video, We will be heading to MLflow, to see how exactly the experiments, model parameters and the model itself are logged, and how we can use this data to compare past run with recent ones.